Chapter 3 review. So, let's do it. Number 1. There is a relationship between smoking status and lung health. Good, average, or poor. People who... I do not smoke. People who smoke tend to have worse lung health than those who do not smoke. Are you shocked?
It's A.
Okay. What is the explanatory and the response variable in this situation? Explanatory variable. What is explaining the response, and what is that response?
It's C. Smoking status. C.
Okay, good. So, smoking status is explaining your lung health.
Yeah.
Does that make sense?
It's good.
Do you guys have any questions?
No.
Fantastic. The answer is C. Very good.
I said A and that's what
Yeah, I saw that. All right. Number 2. Do teachers give more homework on some days of the week than on others? A high school student kept track of how often homework was assigned each day in her class for a semester. All right. So, notice the chart. We've got each day, if they had homework or not. And then we've got these bar charts, or these segmented bar charts. And we need to use the information in the two-way table to determine which segmented bar chart correctly shows the relationship between homework assignments and days of the week. Alrighty. So Monday. What do you guys notice about Monday?
12. It's a good amount.
12 homework out of 18 total. So what is 12 over 18?
66.
66. And what is 6 over 18?
33.3.
Perfect.
33.
So if you just look at Monday, okay, you're looking for the segment for Monday, the segmented bar chart that has homework of 66 and no homework of 33. So,
That takes off C and D.
okay, so that takes off C and D.
Or D, that's on me.
That takes off C and B. Okay, so it looks like it might be A, right? Are you guys with me so far? All right, so let's just look at a few others. So, so check out Wednesday. Wednesday is 9 and 9 out of 18, so that's half and half. So that checks out. Look at Friday. Friday's the opposite of Monday. Okay, so does A kind of look like it works? So very good. Do you guys have any questions on that one?
No.
The answer is A, in fact. All right, number 3. The scatter plot displays the relationship between the area of the 7 continents and the population of each continent. Which of the following provides a correct description of the observed relationship? There is no unusual value in the scatter plot. Do you agree with that?
No.
Why not?
It's an outlier.
45.
Okay, yeah, look at that. That's really way out there. Okay, cool. Do you see a very strong linear pattern?
No.
Not really? Okay, cool. Do you see a positive association between area and population?
Yes.
Larger continents tend to have larger populations.
Yes.
Okay, that one's looking pretty good. Do you see a relationship between area and population that's negative?
No.
No. All right, so what's the answer?
C.
It's C.
C.
It's C. C. Any questions on that one? Perfect. Let's look at the next one. Which of the following scatter plots have a correlation that would be close to 0.986?
C.
You think it's C?
Yeah. How do we know that, though?
Yeah, how do you know that?
Because one is closest to one. It's the strongest.
The closer it is to making a line, the closer it would be to a 1 or a negative 1. Because again, you do have to think about whether it's positive or negative. And so this one was positive, so we do have a positive relationship there. Now, look at A. What would you guys think that A would be close to?
-0.6.
Probably like negative 0.6, 0.7-ish. Okay, cool. What about B?
That's like 1.
No, that's like 0.1.
Yeah.
That's like 0.
Do you guys see a positive or a negative for B?
Positive 0.1.
We don't know. It's a negative.
That's a
That's
positive.
negative.
I mean, I kind of see a little bit of a negative,
I'll give it a negative.
but it would be pretty close to 0. So like negative 0.1, I think that's probably pretty solid. What do you guys see about D? Positive or negative?
Positive.
Positive. And what do you think?
Positive. Yeah, 0.7.
That was probably close to like 0.7, 0.8-ish. Okay. Any questions? So the answer to number 4 is C. Very good. All right. 5. Man, look at us. We're just rocking and rolling. A scatter plot displayed a roughly linear relationship between miles run per week in practice and the time required to finish a race for a random sample of 25 cross-country runners from a recent meet. The correlation for this relationship was found to be negative 0.89. What is the interpretation of that correlation? What does correlation tell you? 2 things. Direction and strength. Strength and direction, direction and strength. All right, so what do you guys notice about the direction here? It's negative. How strong is it? Pretty strong. Okay. There is not enough information to interpret. The linear relationship between miles per week, run per week in practice, and time to finish the race for these runners is weak and negative.
No.
Why not?
It's strong and
Yeah, that's right. The linear relationship is strong and positive. Nope.
No.
How about strong and negative?
Yes.
Let's go. The answer to number 5 is D.
Yeah. Let's go.
Let's go. A student, this is number 6, a student taking advanced math needed a more advanced calculator. eBay.com had several auctions for the calculator. The time remaining in the auctions and the current bid price were recorded. Here is a scatter plot of the data along with the equation of the regression line. What is the predicted bid price for a calculator with 1 hour remaining on the auction? Now, be careful here. What is the unit used for the time? Minutes. So should I plug in a 1?
No.
No. I need to convert 1 hour to 60 minutes. So the predicted amount of price for a calculator with 1 hour or 60 minutes would be. There's 2 ways you can do this. Way number 1 is go to 60 minutes, go to the line, and approximate where that is. About what do you think it is? It looks like it's about 45. Now, how can I get the exact answer?
44.18.
Perfect. I can plug in 60 minutes into the equation for X. Okay?
Yeah.
If I plug in 60 minutes,
That's what I was doing wrong. That's happening.
if I plug in 60 minutes, what do you get as your predicted Y hat value? Yeah. Calculator's probably going to be important. Now, you guys, it's probably going to be pretty close to 45.
44.18.
You think it's 44.18?
Yeah.
Guess what? It is.
Yes.
It is. So the answer would be C. How we doing? How we feeling about this test?
Pretty good.
Easy. No.
It's easy, right? We've got this.
Easy on the review, too.
Yeah, the review's easy, but like we're gonna like those written questions.
We're rocking through this.
We are rocking through this, man. Look at us. We're on number 7. A student needed a calculator for her statistics class. She collected selling price and number of bids received from eBay.com on the same model of calculator she needed to purchase. The equation of the regression line is Y hat equals that, where X is the number of bids received and Y hat is the predicted selling price. Here we go. Calculate and interpret a residual for the calculator that received 16 bids and sold for $60. Now, that's 16 bids and sold for $60. That is an actual value for an actual calculator that was sold on eBay. So, the actual bids, that's X. So X equals 16. It's sold for $60. This is the actual Y value. Was $60. Now, I need to calculate a residual. What should I do to calculate a residual? Good. A residual is the actual Y minus the predicted Y. Y minus Y hat. Now, we have the actual Y, it's $60. How do we get the predicted Y? I'm going to plug X into the equation, and that's going to give me the predicted Y. So I'm going to kind of go over to the side here, and I'm going to plug in that X. So 60.386 plus 0.322X, I'm going to plug in that 16. This is going to give me the Y hat value for a calculator that got 16 bids. So I plug this in, and this gives me the predicted amount sold for a calculator that got 16 bids. So what did you guys get when you plug this in? What do you get for the Y hat?
65. Yeah, 65.53.
Okay, so 65.53. Now, you guys, subtraction order matters, so make sure you do actual minus predicted. So 60 minus 65.53, and then that tells us that we have a residual of what? Negative 5.53. Why is this residual negative? The actual value is lower than the predicted value. So did this calculator sell for more than predicted or less than predicted? Less than predicted. So this calculator sold for 5.54 more? No. Less? Yes. More? No. Less? Yes. Okay. Now let's see what's the difference between B and C or B and D here. The calculator sold for 5.54 less than expected based on the regression line using X is what? What was X? Was the number of bids. Make sure you guys are careful about those details, okay? Cool? So far, that's the hardest one on here. Wasn't it? That was difficult. But we powered through and we got it. All right. Number 8. Man, this student still needs a calculator. All right, cool. A student needed a calculator for statistics class. She collected selling price and bid data from eBay.com on the same, looks like the same equation that we've been working with. X is the number of bids. Y hat is the predicted selling price. Oh, what is the interpretation of the slope and the y-intercept? All right, so how do we interpret slope? First of all, which one is the slope? What number is the slope in that equation? Good. The slope is the one that's with the x, okay? And so what does this number mean? Remember, 0.322x is like saying 0.322 over 1. So my increase in my x is going to be 1. So my increase in number of bids will be 1. And my increase in the y is going to be 0.322. So the predicted selling price for a calculator increases by 60.386 for each additional bid. Okay, so problem number 1 is that, the problem with this one is that is not the slope value, okay? I'm trying to interpret the slope first, then the y-intercept. So that's not the slope value. The selling price for the calculator increases by 0.322 for each additional bid, okay? So remember, X is my bid. So for each additional bid, I get an increase of Y would be my price. So it's always Y over X. Rise over run. So 0.322 increase in price for each additional bid. Does that one look good so far? The selling price increases by that amount for each additional bid. Okay, that one looks good so far. the y-intercept. So the y-intercept is the 60.386. What does the y-intercept tell you? The y-intercept tells you what y equals when x is 0. Okay? So your y-intercept is when x equals 0, y is this value. I don't need your help. Okay, so when there are no bids, so x is 0, the selling price would be 60.386. Does that look right?
Yeah.
Kind of looks pretty good to me. All right, so what's the problem with C? Let's just look at C for a second. It says the predicted selling price for a calculator decreases.
It has to be a negative.
Yeah, there would have to be a negative with the slope. Very good. So that's the problem with that one. And then for D, it says the predicted selling price for a calculator increases by 0.322 for each additional bid. There's nothing wrong with that. When there are no bids, the predicted selling price for a calculator is 60.386. So what's the problem here?
The bid is the y-intercept.
Say that again?
The bid is the y-intercept.
Correct. Oh, you know what? Do you see? Okay, I see what it is. What's the only difference between B and D, y'all? One says predicted. So which one is it? It actually is D. Because of the fact that we are predicting when we're using the regression line. So it is actually D. So B was a distractor, and we almost got distracted. And that's why you keep reading.
Wait, why is it D?
So the reason it's D is because when we are using the regression line, we are predicting values. And so we need to make sure we include the word predicted. I even think that when we took the notes over that section, we actually wrote that down. Like, make sure you write the word predicted. So, yeah, D. D is the one. Cool? Got it? Yes, cool. Perfect. Number 9. So, yes, make sure you use the predicted. Okay, number 9. You're going to have a calculator to do this one. The following table shows the house size in square feet and the asking price in dollars for a random sample of homes for sale in that city. So we have house size and we have asking price. Calculate the least squares regression line for predicting asking price from house size. What do? Calculator. Where do we go in our calculator? Stat, and then where? Edit. All right, stat, and then we need to go to edit. And so we're going to put the house size in L1 and the asking price in L2. We're going to put the house size in L1 and the asking price in L2. Be careful with all those zeros. Make sure you get all your zeros. Okay, once you put your data in, what do you do to get the equation? Good. So we have, where do we go in our calculator? Stat. We go over to calc. And we want number 8, which is the linear regression A plus BX. That's the one we want. And when we go to that and we hit enter, it's going to give us the A and the B. And we just need to make sure that it goes into the format of the equation correctly. So, what does it tell you that the A is?
Here's what I found.
I am not. What does it tell you A is? And then it should be telling you B is 93.626. So, which one is it? If A is that and B is that, then the answer would be C. Does that make sense? Y'all make sure you bring your calculator tomorrow. It's going to be important. All good? All right. All right, y'all. Come on. Stay with me. Are you here? Are you here?
Yeah.
All right, let's look at number 10. Here are 3 residual plots. Which one indicate that the linear model is appropriate? Look at A. Do you guys see a curve pattern?
No.
All right, B.
Yes.
Okay, so is the linear model appropriate for B?
Wait, residual means curve,
Right. So if you see a curved pattern, is the linear model appropriate?
No.
No, right? A curved pattern should be more appropriate. What about C? Do you see what's going on there?
No.
No curve? Okay, so which ones are okay?
B on.
A.
A and C are good. Curve pattern is bad, you guys. That means linear is bad.
I thought we were picking the residual one.
It says, which of these, they're all residual plots. It says, which of the residual plots tell you that the linear model is good? Well, if you see a curve pattern, there's a bad linear model, because that means it's curved. That's bad.
Yeah, I thought we were picking the one that was.
All right. So the answer is D. Cool? Yes.
How is the first one not curved?
Okay, so I know you kind of see that probably, right? But it's like the full pattern. So yes, there's a small little bit there, but it's not overall, like the whole thing does not make a curve. And that's okay, yeah. Good question. All right, we're on to 11. All right, the least squares regression line was used to model the relationship between age and price of a random selection of used Dodge Chargers in a large metropolitan area. The scatter plot that displays this relationship appears below. The standard deviation of the residuals is S equals 4,720.43. Interpret this value. This is straight on just an interpretation of S. There is absolutely no math here. You are just interpreting what that number means. What is the interpretation of the standard deviation of the residuals? It is just the typical variation in the residuals. So, for every 1 year increase in age, the price of a Dodge Charger is predicted to drop by. That sounds like a slope interpretation. So this is more trying to interpret slope. So it's not A. The predicted price of a Dodge Charger is typically about 4,720.43 away from its initial price. Maybe, I don't know. Let's see. So the actual price of a Dodge Charger is typically about 4,720 away from its predicted price using the least squares regression line with X equals age. That sounds pretty good. The actual price of a Dodge Charger is typically about 4,720.43 away from the mean price. No, we don't do anything with mean price there. Okay, so which one is it?
C.
It is C. You guys are very, 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 very correct. So the standard deviation of the residuals. Remind me again, how do you calculate a residual? It is an actual Y value minus a predicted Y value. So the standard deviation of the residuals tells you the typical difference in those values, the actual and the predicted. Got it? Cool. 12. I think, is this our last multiple choice question? Yeah, let's go. A least squares regression line was used. Oh my gosh, it's like the same problem. Now we're interpreting R squared. R squared. So R squared is the percent of the variation in our predictions. So this first one is talking about it being strong and negative. Is that a good interpretation of R squared? No, this is trying to interpret R. B, same thing. It's trying to interpret R. So A and B are off the table. All right, 8% of the variability in age or price. What are we having variability in? Is accounted for by the least squares regression line with X equals age or X equals price. You guys look at the graph and tell me what X is.
X equals age.
Age. So which one is this?
Age.
X is age.
Yes.
So it is C.
Yes, sir.
Yes, sir.
Like all C.
Was it really?
Yeah, it was like all C and D. There's only two with like D.
That is, don't go with that tomorrow, please.
Why is it free response?
Because it's a test, bro. All right, the scatter plot shows the school grade point. The school grade point average on a 12-point scale and an IQ score for all 7th grade students, 78 7th grade students in a rural Midwest school. I cannot read. Describe the relationship. Oh, DOFS. Do y'all remember what that stands for? Direction. Outlier. Form. Strength. All right, guys, what is the direction? Positive. Outliers, do you think that there's any?
No.
Not really, however, if you said that any of those three were outliers, or if you said all three of them were outliers, I would probably say you were right. If you said that there's no real clear outliers, I would say that you were right. So that's kind of a little bit up for interpretation, so, maybe. Form. Is this linear or not linear?
Linear.
Yep. And strength. How strong would you say this association is?
I'm gonna say like 0.7.
I mean, you don't have to give me a number. Weak, moderate, or strong?
Moderate. Moderately
Strong, dude. That's fairly. Did I say fairly strong?
Moderately strong, fairly strong, kinda strong, a little bit strong, strong-ish. All of those would work.
What if we just said strong? Would that be wrong?
Strong, I would take that. Because that one's kind of right there on the line.
Alright.
I think the one on the test is a little bit more clear. This works for me. I'm not picky. I'm really not trying to see if y'all know how to write in sentences. I'm trying to see if you know how to interpret a graph. So there you go. I'll let your English teacher decide your sentence structure. Is that it? Oh no, there's one more. Oh yay, I love part A, B, C, D. Do customers who stay longer at buffets give larger tips? Charlotte, a statistics student who worked at an Asian buffet, decided to investigate this question for her second semester project. While working as a hostess, she obtained a random sample of receipts, which included the length of time in minutes that the party was in the restaurant and the amount of the tip in dollars. Here is the scatter plot of the data. Which variable is the explanatory variable? The time. How did you know it was time? Because it's on the x-axis, y'all. How else do you know that it's time? Because we think that the time is explaining how much tip they leave. Okay? So any of those answers I would have accepted. If you told me it's time because time is on the x-axis, I would have taken that. If you said it's time because time might explain the amount of tip, I would take that. Any of those would be perfectly fine. Okay? So, time is x variable. All right, interpret the correlation. Now, guys, time out. The correlation value is not given to you. So you just have to look at the graph and decide what is the strength and the direction of this association. I am not asking for a number. Okay? So what do you guys think the direction is? First of all, that's usually the easy.
Positive.
It's positive. Okay. How strong do you think this is? Weak, moderate, or strong? Yeah, this is probably weak-ish. Maybe we're inching toward moderate, but it's probably weak. Okay? So this is just basically there is a weak positive association in time versus tip. Cool?
Yeah.
All right. C and D, and then we're done. All right, here's C. Does increasing the amount of time spent in the restaurant cause an increase in the amount of the tip?
Theoretically.
Why not? Say that louder for the people in the back. Correlation does not imply causation. Several of you missed that on your first quiz, your 3.1 to 3.4 quiz. A lot of you missed that. I cannot say that there is a cause here. I can only say that there's a correlation. It's weak at that. So don't ever say anything about there being a cause. Okay, there's not a cause here. So make sure that that's not said. All right, would you be willing to use the regression line for this data to predict the amount of tip for someone who spent 3 hours in the restaurant?
No, that's extrapolation.
Oh, I love it. Perfect. All right, so look. What is the maximum amount of time that was from this data? 100 minutes, which is how many hours? That's like 1 hour and 40 minutes. And now you want me to use this data to go for 3 hours? Nah, that would be an extrapolation. So, would I be willing to use this regression line? Nah, bro. That would be an extrapolation.